Hey guys, welcome to the first lecture that is not in the basement of Evangeline. And I really wish I would be in the basement of Evangeline. Anyway, today sections 5.1, 5.2, the Riemann integral and the definite Riemann integral. To get started, let's take an interval from A to B. And let's divide the integral in n pieces. N pieces of the same length. In our case, how many pieces do we have? 1, 2, 3, 4, 5, 6, 7. So in our case, n would be 7 pieces. But n can be 60, 70, 100, a million. So we divide it in n pieces. Then each piece has a length of b minus a. That's the total length of the interval. And if you divide it in n pieces of the same length, it's b minus a over n. Now, some notation. xi is equal to a plus I times b minus a over n. So what is then x0? So now I is equal to 0. The 0 goes here, so x0 is a. What is x1? Now I is 1. Then it's a plus 1 times b minus a over n. So I start at a and I go b minus a over n to the right. Then I'm here at x1. Because the length of this piece is b minus a over n. A plus 1 times b minus a over n. x2 is a plus 2 times b minus a over n. So I go 2 times b minus a over n to the right, then here at x2. And then I continue this way, then xn is a plus n times b minus a over n, but then the n cancels, and a plus b minus a is b. So here we are at xn. So xi are the partition points if I divide my interval in n pieces. Okay, that was step 1. Now, step 2 is what is called a slicing method. How to compute an area by slicing the area in small pieces. Again, here is a and here is b. And now I have a function, f of x. Nah, that's not a good function, f of x. It's a terrible function, f of x. Let me try it again. So that is my function f of x. So f of x is given. Now, how do I compute the area between the x-axis and the graph? Well, let's take our partitioning points. These are the xi's. And now let's do what is called the left endpoint rule. So I take an interval, and I take the left endpoint, take the height here. So then the height is 0 or very small. whatever the height here is. This is a small rectangle. Now I take my second interval, take the left endpoint, and take here this interval. Then I take x2, take the left endpoint, look at this rectangle. x3, look at this one. Then here xi. Now I compute the area of all these black rectangles. Now, what is the area? The area is the height. So if I take here my interval, then this is xi. The height here is f of xi. So it's f of xi times b minus a over n. Height times width is an area. Notice if f of xi would be negative, then this would be a negative number. So areas under the x-axis are counted negative, areas over the x-axis are counted positive. That's important later. So this is the area now of this rectangle here. And now I do this for all of these rectangles, and I sum them up. Sigma stands for sum. Now my first height is x0, so I goes from 0. And the last height is 1 before xn, so it's xn minus 1. So that is the left endpoint rule. Now the right endpoint rule, similar. So again, I take now from here to there my first subdivision. Now I take the right endpoint and I look at this rectangle. Here is my second one. Now here I look at this one here. I always take the right endpoint from a subdivision and I compute the areas of the red rectangles. Now again, this is called the right endpoint rule. So how does it work? I take my xi, so I take this interval, then the height is xi, I go up here. So then the area of this rectangle is f of xi times b minus a over n. b minus a over n the width, f of xi the height, area of this rectangle. And now I sum up the area of all these red rectangles. And then my first one, the height is x1. So I start from 1. And the last one is at b, which is x of n at n. So the left endpoint rule and the right endpoint rule are basically the same, except left endpoint rule, you sum up all the heights between 0 and n minus 1. In the right endpoint rule, you sum up all the heights between 1 and n. Also important to observe that the term b minus a over n is in all the pieces of the sum, so I can factor it out. So it's really the sum of the heights times b minus a over n. In the same in the right endpoint rule, b minus a over n is in all the sums, so I can factor it out. So it is really the sum of the heights times b minus a over n. Now finally, we do the trapezoidal rule. In the trapezoidal rule, it's nothing but the left endpoint rule plus the right endpoint rule over 2. So it's the average of this number and of this number. If you take the average of 2, you add them up, divided by 2. And the reason why this is called the trapezoidal rule is that if you take a black rectangle like this, and you take a red rectangle like this, so that comes from the left endpoint rule is the black, from the right endpoint rule is the red, And now if you take the average of these two rectangles, the area of these two rectangles, you get the area of this trapezoid, of the blue trapezoid. Makes sense? The black one is this area. The red one is the area of the whole. And if I take the average of these two areas, then I get the area of this trapezoid here. So that means the trapezoid rule is you take these points on the curve and you could connect them with straight lines, and then you compute the area of the trapezoids, and that gives you then an estimate for the area under the curve. So this concludes the first part of the lecture. The second part, we will do examples.